In the sense, if it is a whole number, then for your right half, all the powers are positive powers. 10 to the power minus 2, same procedure. Then multiply the digit with the inverse value. Similarly, if I consider left half, I'm going to have a to the power minus 1. After performing a to the power minus 1, I'll get hello to all, a warm welcome to my new session on data representation. I'm Revati, faculty, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. In today's session, we are going to study about data representation. In the sense, how we are going to represent the data in the computer memory. Dear student, let's see what are the important things we are going to study in our today's session. At the beginning, I'm going to have introduction session. After that, we are going to study the two different types of number system, that is non-positional number system and positional number system. Along with that, we are going to study the different types of positional number systems like binary, octal, hexadecimal and decimal. Now, I'm going to focus on introduction. If I consider digital computer, how the data are represented or how the instructions are stored in the computer memory. Here, computers are only able to understand machine language. So, what is machine language? It is nothing but the binary. That is, binary digits are called machine language. That means, if I consider any digital computers like desktop system or laptop, they can able to understand only machine language, and whatever the instruction or data we are going to have, that is stored in the memory in the form of zeros and ones. For that reason, to represent the data in the form of binary digits, we require number system. The number system uses well-defined symbols called digit. I repeat, whatever the number system we are going to have, and if it uses well-defined set of symbols, then it is called digits. So, number system uses well-defined symbols. For example, if I have 0 and 1, only two symbols, then it is example for binary. If I have 0 to 7, that means 0, 1, 2, 3 up to 7, then it is octal. If I have 0 to 9, then it is called decimal. And if I have 0 to 15, then it is called hexadecimal. So, whatever the number system it may be, it consists of well-defined symbols is called digits. Number systems are basically classified into two types. So, dear student, here number systems are basically classified into two types, that is non-positional number system and positional number system. Now, the question arises, why we require number system? Because whatever the data we are going to have, that is stored in the computer memory in the form of zeros as well as ones. To represent the data in the form of zeros and ones, I require number system. And in that, I am going to use positional number system. So, dear student, let's see what is non-positional number system. So here non-positional number system consists of different symbols. I repeat, here non-positional number systems are made by using different kinds of symbols that are used to represent the numbers. The best example for non-positional number system is our Roman number. If I want to represent number 1 by using Roman numbers, then how can I represent? Here, that is, I'm going to have capital letter I. For 2, I'm going to write same capital letter I twice. For 3, 3 times. So, Roman number system is an example. What is the best example for non-positional number system? That is none other than Roman numbers. And if I write capital letter I, then it is 1. If I write capital letter V, then it is 5. If I write capital letter X, then it is 10. If I write capital letter L, then L is nothing but the 50. So, it's very difficult to perform addition, that means arithmetic operation. By using non-positional number system, it is very difficult to perform basic arithmetic operation. This number system cannot be used efficiently to perform arithmetic operation. So, what kind of arithmetic operation? There is nothing but the basic operations like addition, subtraction, multiplication or division. So, by using Roman numbers, we cannot able to perform the arithmetic operations so effectively. Then, I'm going to have the positional number system. In positional number system, based on the number of positions, we are going to have 4 different types of positional number system. For example, if my number includes only 0 and 1, then I'm going to have binary number system. Suppose if my number system is capable to perform only 0, 1 to up to 7, then what kind of number system? It is nothing but the octal. So what is octal? It is nothing but the 8 digit, including 0 plus 7. I'm going to have 8 digit. And if I have 0 to 9, then this is example for decimal number system. And if I have 0 to 15, then this kind of number systems are example for decimal number system. So what is positional number system? We are going to identify the numbers based on its position. For example, if I consider 0 and 1, here only I am going to have 2 position. If I consider 0 to 7, then I am going to have total 8 position. If I consider 0 to 9, then I am going to have 10 position. And if I consider 0 to 15, then I am going to have 16 position. Based on this, I am going to have 4 different positional number system, that is decimal, binary, octal and hexadecimal number system. Then the total number of digit represents in the any number system is called base. That means the total number of digit that represents in any number system is called base or radix. For example, think that I have only 1 and 0 in my number system, then this is example for binary, and to represent it is binary number system, I'm going to have the base called 2. And if I consider 0 to 7, total it is 8 numbers. To represent these kind of positional numbers, I'm going to have the base or radix, that is 8. And if I consider 0 to 9, how many digits? It's 10 digits. And to represent this kind of digit, I'm going to have the base value 10. And if I consider 0 to 15, it is total 16 digits. To represent 16 digit positional number, I'm going to have 16, that is base 16. So here every number is represented by the base value or index value x, which represents x digit. That means think that this is your number, and to represent the radix or base, I'm going to have x. So here x is used to represent which type of positional number system, either binary or octal or decimal or hexadecimal. The base is written after the number as subscript. So dear student, just remember that whenever I want to represent the base, and how I'm going to represent it? In the form of subscript. That means if this is my number, below I'm going to write the subscript, such as 360 of 10. So here it is 10. So what's the meaning of 10? Here 360 is the decimal number and its base is 10. Then to determine the quantity that the number represents, the number is multiplied by an integer power x. That means if I want to represent the quantity of a given number, then how can I represent? For that, the number is multiplied by the integer power. For example, if the x value equal to 2, then for 2, I'm going to write the integer power. Usually, the power starts from 0 and it's going to take number of digit. So, initially, the power starts from 0. So, to determine the quantity that the number represents, the number is multiplied by an integer power of x depending on the position it is located, and then find the sum of weighted digit. Anyway, I'll explain these statements in the next session. Dear student, to determine the quantity, I'm going to consider this simple example, that is 512.45, and it is of type decimal. To represent it as decimal number, I'm going to write it like subscript. So, first I'll write the position. For 2, I'll give the position 0. For 1, it is 1. And for 5, it is 2. Now, I want to multiply these digits with 10. So, I'll write 2 into 10. What's the power? What's the position? It is 0. Then I will write plus 1 into 10 to the power 1 plus 5 into 10 to the power 2. Then for right side, it is dot, then 4 into 10 to the power minus 1. So here it is minus 1, minus 2 and continues. That means whatever the number that includes fractional point, then I'm going to divide that number into 2 parts, that is left half and right half. And if I consider right half, then I'm going to have the positive number, that is power is positive number. And if I consider left half, then I'm going to have negative power. So this is my left half, that is 4 into 10 to the power minus 1 plus 5 into 10 to the power minus 2. So this is the way I can able to represent or determine the quantity that the number represents. That means if I want to determine the quantity of the number, then I'm going to have this way. That means first find the position, and if it is positive number, in the sense if it is a whole number, then for your right half all the powers are positive powers, and if it is fractional number, and for your left half we are going to consider minus power. So the minus power starts from minus 1, minus 2, minus 3, and it is going to vary. Then I'm going to have the decimal number system. That means if I consider positional number system, there are 4 different types. One is binary, then hexadecimal, decimal, and octal. So at the beginning, I'm going to discuss decimal number system. So what is the decimal number system? Here, decimal number system includes total 10 numbers, but the range starts from 0 to 9. So including 0 to 9, I'm going to have 10 digit. It is the most commonly used number system. So the decimal numbers are represented by 10. That means it includes 10 digit, and the range starts from 0 to 9, and it has 10 digit, hence the base is 10. What's the radix for decimal number? It is 10. These digits can be used to represent any numerical value. That means the decimal number systems are used to represent any numerical value. So here I have some example, that is 140, and it's of type decimal. How can I represent decimal number? I want to write the radix or base, and what's the base value here? It is 10. And another example, 555, and it's of type decimal number. Another example I have here is 3200, and it's of type decimal number. Then this is the way I can able to determine the quantity. So here I have the number that is 542.76 of 10. That is nothing but the base of 10. So what I will do, I will write 542.76, and I'm going to consider left half. This is my left half, and this is my right half. For right half, I'm going to consider the positive power, that means positive number. And for left half, I'm going to consider the negative number. So it is minus 1, and it is minus 2. And if I consider the position here, it is 0, it is 1, and it is 2. So first I'll write the weight. First, what is my first position? That is 2. And what is the weight? 10 to the power 0. And what is my next number? It is 4. And what's the weight? 10 to the power 1. Because 4 is present at the position 2. And if I consider number 5, then it is 10 to the power 2. If I consider fractional value, for 7, it is minus 1, that is 10 to the power minus 1. For 6, it is 10 to the power minus 2. Then what I will do, I'm going to multiply this value with the weight. So 10 into 2. So what is the power? 10 to the power 0. It is 1. By rule, whatever the value or power is 0, the power of given number is 0, then it is 1. So here 1, that is 1 into 2, I'm going to get 2 as it is. And 10 to the power 1, it is 10. 10 into 4, it is 40. Then 10 to the power 2, it is 100. 100 into 5, 500. Now I'm going to add 500, 40 and 2, it is 542. And for fractional value, I'm going to have 10 inverse, that is 10 to the power minus 1 and 10 to the power minus 2. How can I represent 10 to the power minus 1? That is 1 by 10. For 10 to the power minus 2, same procedure. Then multiply the digit with the inverse value. That is your final value. So when I divide 7 by 10, I'm going to get 7 that is 0.7. Then when I find the inverse with 6, I'm going to get the value 0.06. Moving further, I'm going to have binary number system. So the digital computer represents all kind of data and information in the form of binary number system. That means whatever the data we are going to store in the computer memories are stored in the form of binary data. That is nothing but 0 and 1. So the binary number system consists of only 2 digits, that is 0 and 1. So always 0 is low voltage or false value and 1 is nothing but the high voltage or true value. And to represent that, I'm going to have base value or radix, it is 2. Each digit or bit in binary numbers can be 0 or 1. That means whatever the data I'm going to have that is represented in the form of binary numbers means I'm going to have 0 or 1. The positional values are expressed in power of 2. That means if I want to represent the positional value, then how can I? For that, I'm going to have the power of 2. So this is the example for binary numbers. That is 1011 and it's of type binary and 111 it's of type binary, etc. Now this is the table which gives the quantity of the number. So here it is 1101.10 and it is binary number. So what I will do, first I'm going to write the weight. If I consider right half, then it is my positive weight. And if I consider left half, then it is negative weight. Then find the position here. It is 0, 1, 2, 3, and 4. So I'll start with 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. Total, I have 5 digits, but the power starts from 0. So 0 to 4, I'm going to have the power. And if I consider left half, then I'm going to have 1, 0. So here for 1, it is 2 to the power 1, that is 2 to the power minus 1. And for 0, it is 2 to the power minus 2. Now 2 to the power 0, by the rule, whatever the digit power is 0, then value is 1. So 1 into 1, it is 1. So 2 to the power 1, it is 2. 2 into 1, it is 2. And it is 2 to the power 2. That is nothing but the 4. 4 into 0, it is, if I multiply, what's going to happen? It is 0. Then it is 2 to the power 3. That is in the sense 8. 8 into 1, it is 8. And if I consider 2 to the power 4, it is nothing but the 16. That is 2 into 2 into 2 into 2. It is 16. Then I'm going to add 16 plus 8 plus 2 and 1. Then what about fractional value? Once again, I have inverse number. So what I will do? I'm going to write 1 by 2 into 1 plus it is 0 into 1 by 4. Okay, then I'm going to write the sum with my actual sum, because whatever the question I have, it includes integer part as well as fractional part. So first I'm going to find the solution for the integral part, and I'm going to find the solution for fractional part. Then I'm going to have the octal number representation. So what is the number system? It is octal. Octal in the sense it is 8. That means I can able to have only 8 values. So the range starts from 0 to 1. The octal number system has digits starting from 0 to 7. Then what's the base here? It is nothing but 8. The positional values are expressed in power of 8. That means if I want to represent the position of individual digit, for that I have power function. So it is power of 8. Any digit in the system always less than 9. That means if I consider octal number system, then I must have the numbers less than 8. Then this is the example, that is I have 2, 2, 2 and it's of type octal number. Here it is 4, 5, 0 octal number, 7, 0, 0 octal number. If I write 8, 1, 2, then it is wrong. What's the range of octal number? It is 0 to 7, except 7. In the sense, if I write 8, 9, 10, then all these comes under decimal number. So the number that is 6418 is not the octal, because 8 comes under digital number. So that is nothing but the digit. So here 8 is not valid digit. Moving further, I'm going to have the table representation. Now consider the table here. What is the position? What is the 0th position? I have 4. 4 into 8 to the power 0. So what is the power of 8? It is 1. And here I have 8 to the power 1. 8 to the power 1 means how much? It is 8. And here I have 8 to the power 2. That is 8 into 8. It is nothing but 64. Similarly, if I consider left half, I'm going to have 8 to the power minus 1. After performing 8 to the power minus 1, I'll get 0.125. Then what's my next number? It is 8 to the power minus 2. Then after finding inverse, I'll get 0.015652. That's nothing but, how can I write? It is 5 into 1 to the power 8. So this is the way I can able to represent the inverse. Then I'm going to have hexadecimal number system. So what is a hexadecimal? It's nothing but the 16. So if I have 0 to 15 digit, then it is considered as hexadecimal number. So the hexadecimal number system consists of 16 digits from 0 to 9 and A to F. That means a hexadecimal number includes 0 to 15. So 0 to 9, I have decimal number. After that, how can I represent hexadecimal number? To represent hexadecimal numbers, for 10, it is A. For 11, it is B. For 12, it is C. For 13, it is D. For 14, it is E. And for 15, it is F. So, what is the last range of hexadecimal number? That is nothing but letter F. So, the letter A to F represents the decimal number, that is hexadecimal number 10 to 15. That is, A represents 10, B represents 11, C represents 12, D represents 13, E represents 14 and F represents 15. So, how can I write the base here? To represent the base, I am going to have 16. That is, hexadecimal representation is nothing but 16. So, A3 of 16 or 2BC of 16, etc. Then, this is the table used to represent the hexadecimal number. So, this is the example I have, that is 5AF dot D. So, this is my right half, this is my left half. What's the position? 0, it is 1 and it is 2. If I consider D, then it is minus 1. Now, what is my first position? It's 0th position, that is nothing but the 16 to the power 0, then 16 to the power 1 and 16 to the power 2. Now, what I want to do, what is the meaning of 16 to the power 0? It is nothing but 1. Then what's the meaning of 16 to the power 1? It is 16. Then what is the meaning of 16 power 2? Then it is 2, 5, 6. Now what I want to do? I want to multiply these two values, then add all the values in order to get the final value. And for D, first find the inverse. So what is D here? D is nothing but 13. So 13 is D. 13 into 10 to the power, that is 1 to the power 16. So why it is 16? Because it is hexadecimal number. Dear student, to represent fractional value, I am going to have negative power. So it is minus 1. Now I will write the inverse of this, that is 1 by 16 into 13. So what is 13 here? That is nothing but the D. So that is 13 divided by 16. So whatever the value I am going to get, that is 0.0625. Moving further, I am going to have the summary of all the number system. So in binary, what's the base? That is 2. And what are the possibility? I am going to have 0 and 1. If I consider octal number, what's the base? It is 8. And what's the range? That is 0, 1, 2, 3, 4, 5, 6 and 7. Total it is 8. If I consider decimal, then it is 10. So it starts from 0 and it's going to end with 9. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 comes under decimal representation. For hexadecimal, what's the base? It is 16 and 0, 1, 2, 3, 4, 5, 6 up to 9. Fine. After 9, I'm going to have 10. To represent 10, I'm going to have A. To represent 11, B. To represent 12, it is C. To represent D, I'm going to have 13. And for 14, it is E. For 15, it is F. So, dear student, in today's class, we learned what are the different kinds of positional number system we are going to have. In my next class, we are going to study how to convert from one number system to another number system. Until then, keep watching and keep learning. Thank you.